All right, today we are looking at dividing complex numbers, also what we're going to call rationalizing our denominator. Okay, so the issue here with these problems is that I've got an I in my denominator. I'm never allowed to have an I in the denominator. So I need to get rid of that I. Now, if you'll notice on this first page, every problem on this first page, I have a single term in my denominator. There's a single term, a single term, a single term, a single term. They all have a single term. Now the back page, they all have multiple terms. Two terms in the denominator, two terms in the denominator, two terms in the denominator. So we're going to do them differently depending on how many terms are in the denominator. So the first page, if there's only a single term in my denominator, I'm going to multiply by I over I. Anytime you have a single term in the denominator with an I, you're going to multiply I over I. So when I multiply here, 2 times I, it gives me 2I. I'm going to multiply here, negative 3I times another I gives me negative 3I squared. Now, remember your rules. I squared needs to turn into negative 1. So this denominator is actually negative 3 times negative 1. Negative 3 times negative 1 is positive 3. So I've got 2I over 3. Now, if these numbers can reduce, then I reduce them. Doesn't matter about the I. If the numbers can reduce, I have to reduce them. Here, 2 over 3 doesn't reduce, so we just leave it 2I over 3. All right, again, we have a single term in our denominator, a single term. So we're going to multiply again by I over I. Now, here I want to identify my group, because now when I multiply my numerator, I got to multiply the 8 times the I and the negative 7I times the I. Got to do both of them. So when I do 8 times I get 8I. And when I go negative 7I times I get negative 7I squared. And in my denominator, when I go I times I get I squared. Now again, got to clean up these I squareds. This I squared turns into a negative 1, and this I squared turns into a negative 1. So in my numerator, I've got an 8I. When I do negative 7 times negative 1, that actually turns into a positive 7. And now my denominator is just a negative 1, because it was just an I squared, so now it's just a negative 1. Okay, so I want to clean this up a little bit. I need to rewrite this numerator. Remember, I want my constant to be in the front, so my 7 needs to go to the front, and my positive 8I needs to move to the back, all over negative 1. Well, again, there's really no need for a 1 to be in my denominator. So if I'm dividing everything by negative 1, 7 divided by negative 1 turns them into negative 7. 8I divided by negative 1 turns them into negative 8I. So negative 7 minus 8I is my answer there. So again, if there's a single term in my denominator with an I, we multiply by I over I. All right, so on the back page, when we have multiple terms in our denominator, again, we are identifying the groups with parentheses. Okay, in this case, we are going to multiply by what we call the conjugate. C-O-N-J-U-G-A-T-E, conjugate. And what the conjugate means is the only thing that's changing here is the sign in the middle. Okay, so if I'm going to multiply the denominator by the conjugate, it's not going to be 2 plus 4i, it's actually going to be 2 minus 4i. Well, if I multiply the denominator by 2 minus 4i, I got to multiply the numerator also by 2 minus 4i. Got to multiply the same thing in the numerator and the denominator. So when I multiply my numerator, I got to go 7 times 2, and I got to go 7 times negative 4i. Got to multiply them both. 7 times 2 gives me a 14. 7 times negative 4i, negative 28i. Okay, now I got to do the same thing and multiply the denominator. 2 times 2 gives me 4. 2 times negative 4i gives me negative 8i. Now 4i times 2 is positive 8i. And then 4i times negative 4i, positive 4 times negative 4 is negative 16i squared. Now if you'll notice, the I terms here, negative 8i, positive 8i, those guys are going to cancel. That happens every single time when you multiply conjugates together. 2 plus 4i times 2 minus 4i, when the only difference is that middle sign, here's a plus, here's a minus, the middle terms are going to cancel every single time. So really as a shortcut, you could just multiply the 2 times 2 in the front to get a 4, and you could multiply the positive 4i times the negative 4i in the back to get negative 16i squared in the back. Now again, you should have a red flag going off. I squared needs to turn into a negative 1. So I'm going to rewrite this down here. I got a 14 minus 28i. And now I've got a 4. The i's canceled. And now here in the back, you had a negative 16 times I squared. It's actually negative 16 times negative 1. Negative 16 times negative 1 is a positive 16. So now my i's have completely gone away from my denominator. So I've got a 14 minus 28i in the numerator. 4 plus 16 is a 20. Now, I look to see if all 3 of these numbers can reduce. Since they can all reduce, then I'll reduce all of them. If they don't all 3 reduce with each other, then you leave it alone. But here they all 3 reduce. Looks like 2 goes into all of them. 2 goes into 14 7 times. 2 goes into 28 14 times. Don't forget the I there. And 2 goes into 20 10 times. Okay, so now 7, 14, and 10. There's no number that goes into all 3 of those. So I've reduced it as far as I possibly can. I'll show you one more example. Number 13 here. So again, we want to identify our groups. Since I have 2 terms in my denominator, I'm going to multiply by the conjugate. So the conjugate of 9 plus 10i is going to be 9 minus 10i. And same thing on the numerator, 9 minus 10i. Got to multiply the same thing, numerator and denominator. All right, so when I distribute the numerator, negative 9 times 9, negative 81. Negative 9 times negative 10i, positive 90i. 3i times 9 is positive 27i. And then 3i times negative 10i is going to be negative 30i squared. Ran out of room. The denominator, remember the shortcut for the conjugate. The 2 middle terms are going to cancel, so we might as well just do the shortcut. The first number times the first number. 9 times 9 gives me 81. And then the last number times the last number. Positive 10i times negative 10i is negative 100i squared. Again, the I squared is actually going to turn into a negative 1. So negative 100 times negative 1 actually turns this whole guy right here into a positive 100. Same thing happens up here. This I squared turns into a negative 1. So at the end, I've got a negative 30 times negative 1. Negative 30 times negative 1 is just positive 30. So when I combine like terms in my numerator, negative 81 plus 30, we're going to have negative 51. My i's, 90 plus 27i is 117i. And my denominator, 100 plus 81 is 181. And then I'd have to use my calculator to see if those 3 reduce, but the video is just about out of time. I'm not sure if they're all going to reduce. So we're going to